Welcome to this video tutorial. In this video, we'll be starting to build a very small prototype for a VR fighting game in the game engine Unity. For this project, we'll be using NewtonVR, which is my go-to for VR physics interactions. It's available for free on the asset store. And we'll also be using FinalIK and PuppetMaster. They're both paid assets, and they're from Root Motion, and since they're from the same author, they actually work together quite well in the same project without causing too many hiccups. Now, FinalIK so far in this first prototype, we're only using for LookAt behavior so that the dummy actually stares at us while we punch it in the face. That's not a lot of functionality yet, but in the future we will be using this, for example, for the inverse kinematics so that whenever the dummy punches at us, it will actually be able to hit us. So that will be mostly used for the opponent's behavior. PuppetMaster, on the other hand, gives us ragdoll physics, and we can easily blend between normal animations or inverse kinematics provided by FinalIK and then ragdoll physics. So whenever we hit the dummy or our opponent, then we can see how the dummy reacts to that and how it flinches and how it bobs around, and eventually also we can knock our opponent out. But it's really about the impact of our punches, of our weapon hits and so on, and that's what PuppetMaster does really well. Now, you can achieve that in many different ways, but for the purpose of this project, I really didn't want to focus on building ragdoll physics. I'd rather just use what's already available on the asset store and instead focus on the gameplay and on all the different really neat elements that make this a fun little prototype, a fun little fighting game. Now, I had a look around on YouTube and I found another tutorial by FusedVR. So if you're more interested in building something completely from scratch without using FinalIK and PuppetMaster, then you can head over there and see this live stream. And they talk a little bit about sort of using the different built-in physics in Unity to punch out some objects. And then I saw a fairly similar project, which I think is also using PuppetMaster because of the setup and because of the dummies. And that's sort of a sword fighting game, but it's not really a tutorial, it's just a short video of a proof of concept. But that's sort of one of the things that we aim for, that we can actually hit our dummies here with various objects, weapons, and so on. And I'd really like to extend this in the future to make this a multi-part tutorial and extend this over time, because I can already tell you, I didn't invest a lot of time in this first prototype yet, and I tried it myself and it was a lot of fun just punching the dummies. But then what I didn't expect, my wife actually tried to prototype as well, and I couldn't get her off the HTC Vive because she just kept hitting the dummies and giggling away, and that seemed to be a lot of fun. So I really can only recommend just building something small like this and really seeing how much fun and how much entertaining it is if you get the interactions, if you get the physics right. It's really a good experience. So let's get started. Our goal is to have a scene where we can try out punching a number of different dummies and testing a couple different settings, and it should feel natural and be enjoyable. So first we import NewtonVR and PuppetMaster and FinalIK, and our photo structure should look like something like this. We have an audio file, and we just need a sound of some punch. You can either record that yourself, or you can get it from something like freesound.org. Next step is to go to PuppetMaster under plugins and go into the demos folder, and we look for the scene called punching. This scene is probably the closest setup to what we want to achieve. So let's get in that scene and go to File, Save Scene As, and we can call the new scene whatever we like. In this case, I'm just going to call it Scene 2. Once we have this separate scene saved, we can delete the dummy root and the readme probably as well. Can get rid of the main camera. And now we can go to NewtonVR. And when we scroll down, we see NVR player. This will be our new camera, and will also be our control for our hand controllers and our virtual reality setup. Now, when we import NewtonVR, we have to make sure that all settings are correct and that we have SteamVR enabled and installed. Now that is, if you want to use SteamVR, you can also use Oculus. Whichever you want to use, you just go to the NVR player, and then you press the button to install the SDK. As you can see here, I already have SteamVR installed, and then I just need to make sure this little check mark here is enabled. for SteamVR. Now one last thing that we can check, we can go to Build Settings, Player Settings, and here under XR Settings, we have to make sure that virtual reality supported is checked, and then we have to make sure the correct virtual reality SDK is here. For SteamVR, we have to add OpenVR to this list. Now I would recommend for this kind of a game that we use a room scale setup, so either Oculus Rift with multiple sensors or just a SteamVR setup for the HTC Vive. Because it will feel more natural if we can walk around our dummy and just attack him from different directions. So now we could already start just punching this dummy and it would already feel fairly decent, just because this dummy already has some ragdoll physics enabled by default. We don't need to do anything, just use it as it is. Now, the way this dummy works is we have two different hierarchies within this dummy. The first one is the normal dummy, and this is the rig, so all the different bones that we would expect in a normal character. There's nothing attached to each of those bones. And we have an animator component at the root object, the dummy. This will also be the object that will be animated, so any animation will play based on these different bones and will move our dummy around. Here it already comes with a humanoid simple locomotion, in which case the dummy will just stand here and not do much. I think it will just be breathing. Now the important part of this whole dummy is dummy PuppetMaster. This contains a PuppetMaster script, and everything here is already pre-configured with different muscles for head and all the other body parts. And the way this works is we can see here there's a lot of different colliders as part of this body. And while our normal dummy here is being animated, whenever we punch or collide with our dummy with one of those colliders, then the physics impact will be simulated realistically and the animation will be disrupted and will instead follow the physics simulation for a short amount of time. And we have a lot of control over how much we want to blend between the normal animation that's running on this dummy and the physics simulation that is running on this dummy PuppetMaster. In this way, if we punch our dummy in the head, it will start bobbing backwards, just like we would expect when we apply some force. And after a short amount of time, it will resume its animation. That also means that if we want to apply other functionality, for example, the LookAt inverse kinematics that FinalIK provides, we would have to apply this to the normal dummy, so to not interfere with the physics simulation. We can do this here. We can go to the root object of a dummy, and I can add LookAt IK to this object. For the target, we probably want to be looking at the head, at the user's head. So we can go to the NVR player and drag and drop the head into the target. So the dummy will always be looking at us. I'm going to reduce the body weight to 0 just because we don't want the upper body right now to move around too much. Because if we get fairly close to the dummy, it will look awkward because the dummy is going to be bending over backwards. But it's just sort of the kind of setting that you would also just realize during user testing when you try it out yourself and you see sort of what kind of settings feel more natural when the dummy stares at you and moves around as you try to dodge. Alright, next we need to add the head transform. And this is all based on this dummy hierarchy here, which is the actual rig of the dummy. We drag and drop the head in here, and we create a couple of spine transforms, and now have to drag and drop. Let's start with the pelvis, spine 1, spine 2, spine 3, and the neck would be the last one. And we can see already the LookAt IK defines this as the spine. Now it doesn't matter how many objects we include here. The more we include, the more detailed will be the more fluid will be our movement when the LookAt IK solves this spine here, this inverse kinematics chain. So I could also just use pelvis, spine 2, and neck, something like that. We don't have any eyes. As you can see, the dummy is blind. You will also realize, because the dummy is not really punching in your direction, there's no eyes for the dummy to look at you. So this would be rather something if you later on want to swap out with another character. And then you can also add the eyes, and we'll have the dummy actually look you in the eyes or look towards your head. All right, this is LookAt IK, and we can leave this here on our dummy object. Again, make sure it's on the dummy, not on the dummy PuppetMaster. If you put it on the dummy PuppetMaster, then you will see that the Ragdoll physics will not be working because the two systems interfere with each other. We also have a dummy behaviors, and that's the next thing we can tackle. There's a couple of predefined behavior scripts, and we can just add here. Now, if we want to look at those, first of all, let's save our scene, and let's have a look for some of the other demo scenes. So if we go into PuppetMaster Demos folder, for example, go to Puppet Extended, and here we see there's a different character, and there's again the behaviors object, and there's two child objects here, and one contains a behavior puppet script, and one contains a behavior full script. Those are the two most common behavior scripts that will define how the character reacts when you punch them or when you apply forces to certain body parts. And you have different events that you can set up. For example, when the dummy loses balance, what happens then? And then how long does the dummy need to get up again? What kind of animations to use, how to blend, and so on. There's lots of settings here that you can use. What we'll do, however, is we want to simplify this a little bit because there's a lot of values here that are really hard to grasp and really hard to tweak. So let's try to understand these a little bit better and use a script that we create on our own. Now, when we click on the script here, you see there's a whole folder with behaviors and sub-behaviors, and we have the behavior full and behavior puppet here. However, we also have what is called the behavior template. And this is basically an sort of pre-populated, easy to understand version with a few different example functions that we can use and create our own little behavior template for our dummy. So what I did is I copied and pasted this behavior template, so I duplicated it, and then I renamed it to custom puppet behavior. So you can see the behavior template is pretty much empty apart from a couple of basic things that the author here thought was useful for us to use. For example, on fixed update here. So anything that's physics related, we should process in here and on fixed update. Then we have also something like on muscle collision behavior. So when we collide with any of the body parts, with any of the muscle colliders, then there is a collision event that's being triggered. And then whenever that happens, we can actually do something here in this function. And what I did, I created this custom puppet behavior script. So I only renamed the behavior template. And I created a few different things. First of all, collision layer, that's a layer mask, so that we can select which kind of layers we actually want to collide with. So which kind of layers can punch our dummy and create some sort of event or some sort of reaction. We are also keeping count of how many collisions we're achieving. And then a time step collision timer, so basically to keep track of when do we want to reset the number of collisions, so that we can limit, for example, the number of collisions that we trigger once every 0.2 seconds. We can set this number max collisions here, for example, to 1 or 2. And we can also change this time step, for example, limit it to like 1 or 2 collision events per second in order to optimize and to not make this too performance heavy. It also helps us in keeping track of collisions so that when we keep the hand close to the dummy, and the dummy, based on its physics simulation, bobs back and forth just a little bit, so that we don't have like lots and lots of collisions in just sort of one contact. And that was already contained in the behavior puppet, so in the other script, and I copied and slightly modified it to our own script. When we look down here on this on muscle collision behavior function, then when we are beyond the maximum number of collisions, then simply we will not trigger anything new unless our collisions are reset. And the collision reset happens on fixed update. so that we count down our little collision timer here, minus time.delta time. And when it reaches 0, then we reset our collisions. Whenever we do not exceed our max collisions, then we check for the collision layer. So is the object that we collide with actually part of one of the layers that we want to collide with? And if that's the case, we play an audio clip and we add our collisions. We also start our collision timer. Those are the things that are happening here, and the audio clip is the sound of somebody being punched. Now in the future, we might just sort of have some different sounds depending on which body part you hit, so that it sounds different if you just punch the arm or you hit the dummy square in the head. And that's it for now. So all we have to do is we drag and drop our clip in the inspector and we set our max collisions. So let's go back to our scene. We used scene 2. Go to our dummy. And the behavior needs to be added under this dummy behaviors game object. So we create an empty game object. Call it custom behavior. And we add the custom Puppet behavior script. Now the collision layer needs to be set to something that will correspond to what our character is going to be. In this case, I created 2 different layers in addition to the standard default layers. So you go up to layer, click on add layer, and here I added ground and character. Those 2 we'll be using. So our collision layers will be character. And we set our max collisions to 1. And the clip is our punch. And here ground layers, that is already by default existent in this template. So we want to set this to ground. That is mostly for when the dummy falls over and has to get back up so that we have a reference of where the floor is. And one thing we have to do is we select the ground and we set the layer to ground. And our NVR player needs to be set to character so that our dummy knows that it can get punched by this character. Okay, now there's a few other things that we can consider. One of them being we can look at the left and right hand of the NVR player, and we need to decide what do we want to do in order to punch our dummy. The important thing here is the hold button. The hold button basically decides which button to press in order to create a solid object out of our controllers. Usually, when you don't press any button, you just can intersect with any object in the scene. However, when you hold that hold button, then our controller is solid and it cannot intersect with other colliders anymore. So when you want to punch the other dummy, then you will have to hold that hold button. And the grip button on the HTC Vive controller is a little bit harder to hold over time than, for example, the trigger button. So let's just swap these 2. Now in the future we can decide, do we actually want to get rid of the hold button altogether so that our controller is always solid so we don't have to hold any button? Or if, for example, something like using weapons is important to us, so if we want to be able to pick up like a sword or a baseball bat in the future to beat up our dummies, then it is still important that we make sure that we have a hold and a use button, because you want to be able to hover over your weapon and then you hold the use button in order to hold that object in your hands. But for now, let's just swap these 2 here, and we have to hold the trigger button in order to punch. If we don't hold the trigger button, our punch will go straight through the dummy and have no effect. And we swap these 2 on the other hand as well. Okay. Now if we build this, then we can already start punching. We will hear the sound, and we will also get the response of our dummy. There's a few little things that we can optimize, and that I also optimized in my other scene that I already built in advance. Just going to switch over to that one for now. I have 3 different dummies. I was just testing different configurations and different values in our PuppetMaster scripts. But one thing I did, when I go to the PuppetMaster, You can see that some of those colliders are a little smaller here. So I downscaled some of the colliders. And that is just to make the collision a bit more accurate. One thing I haven't adjusted yet is the chest. That's probably the most problematic one. You can see here, so if I were to punch the dummy down here, sort of at the abdomen, then the collision would happen way before we actually touch the body. And that will be noticeable to some degree, depending on how much you pay attention. Same goes if you kick the dummy in the butt. You would again see that we don't have very precise collision down here. So we would have to scale this collider to have some more precise collisions. That's something that we can do to optimize. I would also suggest probably using a capsule collider instead of a sphere collider for the head to have a bit more of a realistic shape up here. Okay, and that is it for now. And that will conclude our first tutorial. In the next tutorial, I will see how we can maybe add some different characters and how we can have some blood spatters and just a few more details in order for our dummy to actually use animations, different animations. We have here in this setup, the middle dummy here will actually be punching already, but since we don't use inverse kinematics right now in FinalIK for these punches, the dummy will just like punch regardless of where I am. It will just be a forward punch, so just a pure animation. In the future, we want to augment this by using our NVR player, so us, and our head ideally, as a target for the dummy to be able to punch towards. And that will make it much more dynamic. In the short video of this scene working and me trying out, you can already see that we can already achieve a lot by just using this setup as it is right now, because as the dummy punches, I can already put my controller in the dummy's way and basically block the punch. While it's still a little bit awkward, it's already a good basis to start with, so that we can in the future be able to block incoming punches and then do some counter punching and really knock the dummy out. That's it for now, and I hope you enjoyed this little tutorial, and we'll be expanding this in the future. Thanks for watching. I'll see you next time.